All right, so we're back to recording again.
Oh, that's because you didn't do negative.
And so
you did regular too.
here we are looking
For
at homework
40
set number
minus 42.
14,
I probably should.
starting on page 484.
I want to make sure he did.
And so we're looking at the question of gambling. And we're doing a hypothesis test about gambling. Specifically, we need to know what is it that we are measuring. What's this hypothesis test about? Okay. Now, you should have your list of procedures with you, okay, for this. Fritz, you're going to have to find some place to sit because you got to move because of the camera. So what we have here is a hypothesis test, so you should have your list of procedures for hypothesis testing. You need to have that paper out. It needs to be on top of everything else. If you have anything that gets on top of that paper, you're going to move it so that you can see that paper all the time. You have to have that paper in front of you in order to know what you're doing. Jennifer, do I have an chair? Yes. Okay. So, April, what's our first step? Okay, so can you give me hypotheses here for number 4? Okay, so we start H0. U1 equals U2. So we're talking about averages. And then we're looking at 2 different samples. We call this independent. Okay, we have 2 different groups that are being sampled here. And then it depends on which one you call number 1 and which one you call number 2 as far as what's going to happen next, right? So, I want to know what the sample values are. All right, Lee, can you tell me what the sample averages are for this problem?
X1 is 48.7.
Okay, it's actually X bar 1,
X bar 1 is
48.7.
30.7.
Okay.
And then X bar 2 is 55.3.
I'm sorry, 55.3?
Yes.
Okay. So then what's your alternative hypothesis, Lee?
U1 is less than
U1 is less than U2. All right? This is how it works. We look at the sample values. The sample values tell us what direction we can prove regarding the population. Now, your textbook doesn't always work this way. Okay? Sometimes the textbook will say, can you find a difference between them? And it will consider them to be two-tailed. We're not going to do that. What we're going to do is look at the actual sample values, and then that's going to tell us the direction of the test, so it's going to be one-tailed. All right? Nikki, what's next? Okay, so we're going to find the critical value. Where are we going to look for the critical value?
Table F.
Table F, which is the T table, and where are we going to look?
Under 24.
Why are we looking under 24?
Because this is the lowest sample size minus 1.
Okay, so this N1 was 25. This N2 was 35. So we're going to take the smallest sample. We're going to make degrees of freedom to 24. What else do we need to find critical value?
We need
Alpha.
Alpha.
Okay.
0.05.
All right, so we're going to use alpha 0.05. And when we look that up, we see a 1.711. Why did I put that as negative here, Jake?
Because you're looking for what's in the rejection region, and you need to do that to properly carry through this problem.
Oh, well, yeah, it is the right way to do the problem, but that's not the only reason why I did it, okay? Okay.
I know.
I don't know that.
Okay, Sarah?
Maybe because it's less than?
It's because it's less than. It's a left-tailed test. And when we're doing left-tailed tests with t-scores, 0 is in the middle, so down here we have negative 1711. Okay? Because it's left-tailed, it's going to the left. It's less than. And when we're looking at a left-tailed test with t, that means it's a negative number. And Jake is now a little bit wiser than he was a few seconds ago, right? Okay. So, what's our next step then, Vanessa?
You have to find the test value.
We have to find the test value. We need the formula for the test value when we're doing the difference of two averages. And that formula is t equals x bar 1 minus x bar 2 divided by the square root of s1 squared over n1 plus s2 squared over n2. Now, in the formula, it also has mu1 minus mu2, but that's 0 because mu1 is equal to mu2, so we don't really need that part. So here's the formula. We put in those numbers, and hopefully we get negative 4.509. Okay? That's what's supposed to happen. So, Vanessa, can you tell me what my next step is?
I think after that you can make a decision.
That's correct. We need to make a decision. All right? So, Danielle, can you tell me what decision I need to make? Okay. Ta, can you tell me what decision I need to make?
Reject null.
I reject the null hypothesis. And why do I do that?
Negative 4.509 in the rejection region.
That's correct. Because the test value is in the rejection region, I reject the null hypothesis. Okay? So then, Alex, what does that mean when I reject the null hypothesis?
That you accept H1.
Okay, I accept the alternative, or in a sense, I prove the alternative. H1, prove it. Okay. So, Alex, can you tell me then my conclusion?
With a 90% confidence,
Actually, it's 95% confidence because it's 0.05 here. Okay.
correct.
Okay, with 95% confidence, what?
There is evidence
There is evidence, correct?
that percent.
No, sorry, not correct. Katie, what's...
Well, I have that with 95% confidence, there's evidence to prove that the claim that the mean age of those claims...
Okay, sorry.
Okay.
Okay, when we go through our list, amount of confidence, is or is not evidence. What's the next thing?
The
type of
mean
measure.
age.
Okay, what thing are we measuring? Okay, so we say, see if I can make this happen, with 95% confidence, there is evidence that the population mean that's what we're measuring. All right? So Katie, what are we actually measuring?
Population age
Age
of those playing slot machines
of slot people, right?
is less than
Is less than
those playing roulette.
roulette. That's correct. Okay? It's important that you're able to understand where these things come from and what they're telling you. Okay? First of all, we have to have the amount of confidence based on what alpha used. Then maybe the most important thing about this problem is what the actual thing is. What's the actual conclusion? There is evidence to prove something. And then we have to say what it is we're talking about. It's not the proportion, it's not a percent, it's not the standard deviation, it's the population mean. And then we have to say what are these numbers actually measuring? We're measuring age, and then we have two different places where these numbers are coming from. Those who are playing the slot machines and those who are playing roulette, and we have a direction of that difference. It is good for you to understand the numbers and to be able to put things into your calculator and get them. But if you don't get this, you don't really understand what's going on with the problem. Right? You have to know what you're actually measuring and what you're actually comparing and what you're actually proving. Having the numbers correct is good, but it's not good enough. Especially if you want to actually know what you're going to do with this stuff when you get done with it. Okay? Because this is what we're doing. We're actually proving that people who play slot machines are younger on average than people who play roulette. Now, does that make a difference in your casino marketing plan? Probably, right? So then you have all kinds of things going on in your business, whatever your business may be, because I hope that when you get out of here, you're actually going to be engaged in business somehow. But no matter how you're going to be using this, you're going to be looking at numbers that tell you something about a group. And you're going to be comparing it with another one. And then you're going to make decisions on what that means for your work life. Okay? And so you need to be able to understand how to put it into this form, to understand what it is, so that you can understand what kind of decision you want to make. All right, so there's number 4. Any questions about number 4? Okay, number 6 looks a lot the same. We're talking about comparing two averages, but now we have greater than, so it's a right tail test. So we're looking at a positive number. We get the test value, we get the critical value. Same process. We come out, reject the null hypothesis, so that we say elementary school teachers are getting more money than secondary school teachers. Okay. So, any question about number 6? Looks very much the same as number 4. All right, we'll move on. Certainly if you have questions, we can come back, but we'll move on for now. Go to page 497. Page 497. We're no longer talking about comparing two averages. Joseph, can you tell me what we are actually doing here on page 497?
This is when we're comparing the sample set of dogs who are not on the diet versus ones who are on the diet. And their change in weight.
Okay, we do not have two different sets of dogs. Okay. Nikki?
Before and after.
It's a before and after. Okay. It's a before and after, and what name do we give this hypothesis test then?
We have to
This is a matched pairs hypothesis test, also known as a dependent.
It's very difficult to use.
Sample. Okay, so we have the same group measured twice. We do not have two different sets of people or things or anything else. We have the same group which is measured twice. Okay. So, Ta, can you tell me what the null hypothesis looks like for this? U sub D is equal to 0. So what we're looking at are the differences in the weight of these dogs. So if we go to my sheet here, and make sure my advertisements are blocked. Okay, so here we have before and after. And so what we're going to do is subtract these different weights. Now it depends on the order in which you subtract them as to whether you get a positive or a negative number. So Todd, did you get a positive number when you took the first? So 42 minus 39 gives you the number 3. So how would you interpret that number 3, Todd? What would you call that?
I would say that after the medication or after the sample.
Okay.
Yeah.
Okay, the dog lost some weight. Okay. So the dog lost 3 pounds of weight. And so what we have here then, these differences are giving us how much weight was lost by each dog. So those differences are now the data set that we're going to use. So we need the mean and standard deviation of that data set. Now hopefully you recall that we went through this, how to do this on a spreadsheet so that you wouldn't have to go through by hand and figure all these pieces of information, especially standard deviation. So that you can type this into Excel, do the subtraction, find the averages, and find the standard deviation. So we come out with a couple of things here.
Well, I did it
Okay.
Now you got.
Oh, okay.
Get it both ways.
All right. Yeah, I have to draw. Oops. Okay. So what we have here then is that if we're going to find this average, if we do it by hand, we add them up and then divide by 6. Right? Where did I do that?
I got 29 minutes.
Okay, that's the sum, but then we have to divide by 6 to get the average. Unless you're, yeah, well, however it's going to have to, okay? My documentation is for those of you in computer science, this is a bad example. You're all supposed to put documentation. So this. So the average is 4.83.
Okay.
Okay?
Do you need it? Do you need the average?
Yes, we do need the average. Nikki, can you tell me what symbol I use for that average?
D-bar.
D bar. So D bar is equal to 4.83. Okay. Now, since this is a positive number, that tells us what we want for our alternative hypothesis, mu sub D that is greater than 0. So what we're saying here is that these dogs lost weight. On average, they lost an average of 4.8 pounds. And supposedly that's what we want. And so if that's what we want to have happen, that's what we want to prove. That this thing actually causes dogs to lose weight on average. We're not saying it works for every dog, but we're saying that if you take the average, it actually does make a difference. This much of a difference. Now this could just be a random fluctuation, or it could be a true reflection of something. So that's what we want to prove. So we have the null and alternative hypotheses. Jake, what do we need next?
I didn't understand this problem. So
Okay, hopefully you have your list in front of you. After you do the null and alternative hypotheses, you do something next. Unfortunately, you don't. So that's Vanessa. What happens after the null and alternative hypotheses?
You need to find the critical value?
We need to find the critical value. That's correct. So the question would be, where do we look for that critical value? Vanessa, can you tell me?
T-test, so you use table F,
Okay, we are doing the t-test. We're on table F. Yes, we are.
and then you have the sample minus 1, so degrees of freedom is 5.
Okay, degrees of freedom would be 5. And we'll have an alpha here, I hope.
That's 0.05.
Alpha is 0.05. So what do we get for a critical value then, Vanessa?
2.015.
2.015. Okay, that's right. Now, Jacob, you might redeem yourself here. What's next? After we find the critical value, what's on your list? Oh, no.
find the test value.
There we go. Find the test value. All right. So now you need a formula for that.
I know that.
Yeah, that's all right. We'll beat it out of you eventually here. Yes. Question.
So the 5 is, we got that from the sample size.
That's correct. The sample size is 6. There were 6
Okay,
dogs.
minus.
So then minus 1 is 5 for the degrees of freedom.
That's what I'm
Okay. And again, recall that what we're looking at here is actually the list of differences. There are 6 numbers in our list of differences. So 5 would be our degrees of freedom. Okay. So, Sarah, can you tell me the formula for the test value for this problem?
Yeah, T equals D bar minus,
U,
mu little d
U, D,
divided by standard
just the letter.
S
S,
little d
S, D,
divided by the square root of n.
divided by square root of n. Okay? There are a couple of different standard deviations, so we just use the letter S. Okay? Now, in this situation, mu sub D is 0, so we can just take that out. We don't need that. So it's just D bar divided by S sub D over square root of n. S sub D, then, would be the standard deviation of those data values.
Yeah.
Standard deviation of those data values is 3.87.
I have a question. That
Sure.
you follow the steps on the book and like that, and I'm not sure if I understand
Okay, what do you have? Okay. This right here, okay, these are your data values.
Oh, all right.
You got 29 here.
Don't even use that.
Yeah, this would be, this is not, okay, this is 215 and that's 6. And that's 29 squared. Okay, let me just multiply that out. So you have 6 times 215
I got 2.5.
minus 849. 449.
And then so what's the little d in standard deviation?
Yeah, something happened here.
Standard deviation, and then what's the little d difference?
Because this on top of 449, and then you divide by this,
I have my numbers all messed up.
Here, I'm the head.
that should be 10.6.
Oh, maybe that's just
No.
sample deviation. SD equals sample
Okay,
deviation.
you need to do this again.
So they're not two
all right?
separate.
You do the top of the fraction,
Oh.
do the bottom of the fraction, divide them, and then take the square root of it. Okay?
Divided by
Pardon?
That's the number now.
Okay, so knowing how to find the standard deviation is good, but unnecessary. Okay, I'm not going to ask you to find the standard deviation ever again. So you don't have to know how to do it at all. Okay? So if you take a whole lot of time saying, boy, I really want to know how to find the standard deviation,
Forget it.
forget it.
So you
You
say
don't
that
have to know how to do that.
our best
Okay.
ways to do this stuff is to do this.
Because what I want you to be able to do is hypothesis testing. Hopefully you'll be able to type in equals STDEV parenthesis, put your data in there, and get the number directly. You don't need to do it by hand. You need to understand hypothesis testing. That's what we're about. Okay? Now certainly, a few weeks ago, you had a test on which you were supposed to do the standard deviation. So that knowledge is located somewhere in your cerebral cortex. However, it doesn't matter right now, because this is the important thing. Can you do hypothesis testing? Okay? Hopefully that clears up a little bit. So then when you put 483 up here, divided by 1.58, whole square root of 6, come out with the test value,
You need 3.87.
which is 3.
Yeah.
Yeah.
3.7 instead of 1.8.
Oh yeah, that's right.
Okay.
Put that in there. When you divide by square root of 6, you get 1.5. So then you come up with 3.06 as your test value.
Ryan was .106 the first time.
Ours is not trees and wine.
I have the exact same thing written down as you.
Yeah, okay. So let's not do that anymore. Yeah. Those divided by signs. Okay. And I did notice that on some of the homeworks that were out there. What's on the bottom of this fraction is divided. It's not multiplied. If you multiply, it's completely wrong. You'll get a complete wrong answer. Don't do that. This should be divided here inside that fraction. If you write it as multiplication on your test, that will be psychologically disturbing for me, even if you do get the right answer. So don't do that.
You know I'm going to do my homework.
Yeah, there we go. All right. So yes, you do have an opportunity to correct your homework. That's a good thing. So here we are then with the test value and the critical value. All right. So, Lee, what do we do next?
We make a decision.
Okay, and what decision do we make?
We are going to reject the non-positive.
That's correct, and what does that mean?
It means, do you want me to summarize this?
No, just tell me the short answer.
We are accepting the alternative
Okay, which tells us what?
that this dog lost weight.
Sorry, that's not correct. Okay, we don't care about the sample.
That MOC is...
No, sorry, not correct. We don't care about numbers either. Okay. Short answer, it worked. Okay, the diet works. Right? Yes, the 6 dogs did lose some weight, but that's not what we're after. We don't want to know about the sample. We want to know about the population. Does this work in general? And the answer is yes. Okay, Lee, does that make sense?
Yeah.
Okay.
Can you draw that on that graph thing, like it's not in the region, right?
Okay, so what we have right here, our critical value was 2.015, which is here. Our test value, 3.16, is here. So the test value is in the rejection region. So we reject the null hypothesis.
Thank you.
Okay. So, rejecting the null hypothesis means we prove the alternative. And that's what we're after. That's what we're trying to do. We're trying to prove the alternative. When we prove the alternative, then we have to know what it is we're proving. When we're talking about differences like this, what we're trying to prove is that the difference is real. And we're talking about a population. That if this were to happen to everything in the category, it would be different. So we don't usually look for the long form of the conclusion. We don't say with 95% confidence there is evidence that the average of the differences in the population mean for dogs on a diet is greater than 0. We don't say that. What we say is the diet works. So you need to know the short form of the conclusion when we're talking about differences, because that's what we're trying to prove. Okay. So then we look at number 10. Number 10 looks a lot like number 8. But now we have a sample of 6 music students. And so then we have the same type of thing happening here. The average of those differences comes out to be 3.5. The standard deviation of those differences comes out to be 2.88. So those are the numbers that we put in for our test value. We get a test value of 2.976. Once again, we reject the null, prove the alternative, and then we ask the question, what is the answer? Katie, can you tell me what the answer is for number 10?
The summarizing part?
No, the short answer.
Oh, the short answer that we, that, hold on. After the number of mistakes was goes less.
That's correct. After you practice, the number of mistakes goes down.
So we don't use the whole 95%?
We do not. No, we don't.
Okay.
Okay? Why not? Because it's crazy.
Okay. And it's hard to remember.
And it's hard to make sense of it, right? What are we actually talking about? It's crazy. So we don't. We just say, did it work? Yes, it did. When you practice, you make fewer mistakes. Well, let's hope that's generally true of most things, right? We've now proven it here with these music systems. Okay. All right. So, it is important for you to be able to understand the concept of the matched pairs test. You don't have to necessarily know how to find the standard deviation and go through all those steps, but you do need to know what it's talking about. And if you saw the calculations, to be able to interpret them properly, so that you can say what it is you're actually proving and what difference it makes, whatever thing is happening here. Okay? Any further questions about numbers 8 or 10? Okay, so let's go to page 506. And now we're talking about the difference between proportions. This is more like we had for that first section. Calculation is a little bit more complicated. So we're looking at different places where the male carriers are getting bitten. Notice they did not say bitten by a dog. They said bitten by an animal. So if you have whatever bird or reptile in your apartment, stop them from biting. That's right. Don't deliver mail to zoo. That's what I'd say. Okay, so now we're asking the question, is there a difference in the proportions between these things? So, April, can you tell me what H0 would be in the situation?
H0, P1 equals P2.
P1 equals P2. And now, April, can you tell me what P1 hat would be and P2 hat?
P1 is 0.137.
All right. So that would be 10 out of 73 and 16 out of 80. So then based on this, Joseph, what do you have for alternative?
P1 is not equal to P2?
No, that's wrong, because we're looking at the actual samples
Then
here.
we'd say that P1 is less than P2.
P1 is less than P2, that's correct. Now that's not how the textbook does it, but that's how I do it. Because if we have the sample, then we know which direction we're actually going. Okay. So, Alex, what's our next step?
Find the critical value.
Okay, so where do I look to get the critical value? Wes, can you tell me?
I probably have it written down.
Okay, but it's not nearby. Lee, can you tell me?
Yeah, table F,
Okay, where on table F?
alpha 0.05,
Okay.
goes down to the C and bottom.
Okay, so we go down to the bottom, we're looking at Z. Whenever we're measuring proportions, we're considering Z-scores here. So then, for this, we're going to have what kind of a picture? Nikki, what kind of a picture are we going to have here?
You'll have negative 1.645.
Negative 1.645, because what? Okay, it's less than, so it's left-tailed, negative 1.645. Okay. So, Jake, how about the next step? What do we need?
On the test value,
Okay, what's the formula for the test value?
Z equals p hat 1 minus p hat 2 minus p1 minus p2 over the square root of p bar times q bar times 1 over n1 plus 1 over n2.
Okay. And what's the formula for P bar?
X1 plus x2 over n1 plus n2.
All right. So this is the formula we're using for test value. Q bar is 1 minus P bar. And so we put all these things into the formula, and hopefully we get a test value of negative 1.037. All right.
that just be
Yeah, you
rounded?
might have rounded off your P bar
Okay.
or P hat 1. Okay. Generally, it's good for us to have 4 decimal places when we do calculations like this, so that when we get down to the end that we have sufficient accuracy. Okay. If we go to 3 decimal places, we still might get close. But if you round off just the 2 decimal places, you might not get the same answer. So generally, in this process right here, you're going to want 4 decimal places to do this. Now, my recommendation is that you allow your calculator to do most of this, so that you don't write down every number as you go through every step. That would be a lot of work. And it's not necessary if you can make your calculator do the work for you. So once you come up with a P bar, then you can get a P bar and a Q bar. You can hopefully do this bottom part of the fraction just on your calculator. Just hit square root, parentheses, this number times this number times parentheses, 1 over n1 plus 1 over n2, parenthesis, parenthesis, equals, get this number. And then have the subtraction divided by that number gets you the result. And again, keeping enough accuracy in your calculations to make that happen. Certainly it's worthwhile to make this work, because on the exam you are going to be doing this. So you need to know how those buttons on your calculator can get that answer.
Can you just do it with all the numbers? Just set it up.
Okay. Can I do it with all the numbers? Yes. The question is, can you do it with all the
No.
numbers? Okay. So what are you putting in here for P1?
I have 0.137 minus 0.2.
Okay, what do you get for an answer when you do that?
Negative 0.063.
Negative 0.063. What do you have for P bar?
as I got. That's what I got.
Okay, so what's the formula for p-bar? x1 plus x2 over n1 plus n2. So in the problem, what does it say that x and n are for each of these?
73 and 80.
Okay, so 73 and 80 would be, are those x or are they n?
N.
N. So what's 73 plus 80?
$153.
That's going to be on the bottom of p-bar. What's going to be on the top?
10 plus 16.
What's 10 plus 16?
26.
Okay, so p-bar is 26 over 153.
0.169.
0.169. That's p-bar then. So now I need q-bar, so that's going to be 1 minus that.
And that answers my question.
Okay.
I couldn't get Q bar.
All right. So 1 minus 0.169 is 0.831. Okay. So then we would take square root of, in parentheses, 0.169 times 0.831 times, in parentheses, 1 divided by, what is it? 73. 73 plus 1 divided by 80, parenthesis, parenthesis, equals. 0.06066. Okay. Now it's also helpful on your calculator, there is a button that brings the answer back. So that after you would get this number, which on the bottom of the fraction, you could take negative 0.063 divided by the answer, and then give you that result, which I get negative 1.039, which is pretty close to that. All right, Jennifer, does that answer your question?
Yeah.
Okay. Now, what do we do after we get the test value, Vanessa?
We make a decision.
Okay, what decision do we make?
I have no decision.
That's correct. Okay, why do we say no decision?
I don't remember why.
Okay, Sarah, why do we say no decision?
Because it is in the rejection region.
Well, you had a 50-50 chance. Unfortunately,
It's not.
it's not in the rejection region. Okay? This number, negative 1.039, is not in the rejection region, so we do not reject the null hypothesis. So that means we say no decision. There is not evidence proven. Okay? So when we get done with the hypothesis test, what are our two things that could happen? If this is in the rejection region, test value is in the rejection region, then we reject the null hypothesis, we prove the alternative, there is evidence, and then we have an answer. That all happens if it's in the rejection region. We reject the null hypothesis, we prove the alternative, there is evidence for this, we have an answer. If the test value is not in the rejection region, we do not reject the null hypothesis, there is not evidence, and so we say no decision. It's really important that you get the difference between those two things. If you go through an entire problem, get all the numbers correct, and get down to the very end, and you say reject the null hypothesis, and then after you say reject the null hypothesis, you then say no decision, your entire problem is wrong. Because this is the conclusion that you're supposed to draw. If you draw the wrong conclusion, it's completely wrong, because you did the wrong thing at the end. You have to know the difference. You have to be able to recognize this. This is the most important thing. Let's see, I said that twice. So I might say it a few more times before we're all done. If you go all the way through everything and you put the word not, and you're not supposed to, or you put the word is, and you're not supposed to, your problem is completely wrong. Because that word, not, makes all the difference in the world. Is this true or is it false? There's really only two choices, and you have to choose the correct one. Is there evidence or is there not evidence? In this situation, we say there's not evidence. What we are actually saying then has to do with mail carriers getting bitten. So what we are saying is we cannot prove that there is a difference in the proportion of mail carriers bitten in this city versus this other. There is obviously a difference in the numbers, 13.7% versus 20%, but that could just be a random fluctuation. We cannot prove that that difference is really significant. We don't have enough evidence to prove that. Okay? Any further questions about number 6? Or number 16 for that matter. It's the same thing, right? Okay, on-time arrivals. We need P1 hat and P2 hat. So what's P1 hat, Alex?
213 divided by 300.
Which would be what?
0.71.
Okay, what's P2 hat?
0.74.
So what's your alternative hypothesis then, Alex?
That's P1 is
Okay, you were good when you were looking up here at the board. You were comparing these two numbers right here.
P1 is less
Than P2. Okay? From the samples, we are able to make this decision about which direction to go. Okay? We have the sample numbers. They're telling us that one of these proportions is different from the other one. Now what we're going to try to prove, is this a significant difference? Or is this more of a random fluctuation between them? Okay? Now I'm certainly willing to help you, but if you don't have these two numbers, you're not going to get very far. Because this is all you need to do is put all those numbers in here, use your X1 and X2, N1 and N2 to get your P bar, Q bar, and all that happy stuff. Katie, you have a P bar for this thing?
P bar, I have 0.7237.
Okay, so then Q bar would be 0.2763.
Oh, never mind. Got it.
Okay.
Got it.
Now specifically, they asked us to do this with an alpha of 0.01. Joseph, can you tell me where I get my critical value then?
Critical value can be at table F. Go to 0.01 tail and bottom of the chart, Z-score.
Okay.
It's 2.326.
All right. Now, if you set up the problem the way that we have it on the board, these would be negative numbers. But you certainly could set it up the other direction, where they would be positive numbers. Doesn't matter, as long as you're consistent. So you could have either positive numbers with a greater than or negative numbers with a less than, depending on how you set up your P1 versus P2. Either way is fine as long as you're consistent. Right? So then the big deal, I don't know if you call it big deal, but one of the bigger deals here is that you're actually able to calculate the test value properly, because it just takes a pretty hefty amount of calculation to make that happen. But if you do, and you come up with something at least close to 0.78, then the rest is just the same as it's always been. It does not get in there, and it doesn't make it happen, and everything like that. Now, Jake has a question. He's talking about having it negative. Okay. If you did P2 is 0.74 and P1 is 0.71, that makes a difference now. If you talk about it the other direction, that's okay. And then as long as your critical value is also negative, then you're still okay.
See, I did mine the same way you have it though, with P1 as being 0.71 and P2 being 0.74, and I get negative
Yes,
0.7.
you get negative. Okay? This, do it this way, then those numbers would be negative.
Oh, okay.
Okay?
Which is fine.
Which is fine. Yeah, it's okay.
So you did it, okay.
But if you do it the other way, and the numbers are positive, that's also. As Tevye said in Fiddler on the Roof, you also are correct.
Then no decision because it's not in the rejection region.
Correct. No decision because it's not in the rejection region. So we ask the question, is there a difference between airline A and B? And the best answer is we don't know. We found a difference in the samples, 71 versus 74%, but that difference is not significant because of situation with our sample sizes and so on. We don't know if that's really a true difference or just a random fluctuation.
And would we do our long form answer for this one as well?
We can do the long form answer for this one.
Would you?
Sure I would. Can we? Yes. Should we? Yes. Will we? Yes. Right? All those things are true. So what we would say is with 95, or actually 99, with 99% confidence, there is not evidence to prove that the population proportion of on-time arrivals for airline A is less than airline B. Alrighty then. So we've got our 6 different hypothesis testing problems here, each of whom has 6 parts. So that's probably fruitful ground for discussion here. Are there any questions at all about any of these problems?
For number 16, my n is under 1 over n. I think
Right.
I have the wrong sample sizes because I'm not getting it right in my thumb.
Okay, so then your sample sizes are 300 and 250.
Okay, that's one.
Okay?
I had different numbers. I had 213 and 181.
Okay. All right, so yeah, that's a good question. All right, any other questions about anything?
Can you explain more about how do you know how to use the last and the equal sign?
Okay, so then when we have our null hypothesis always has the equal sign. And then we're going to look at the actual sample data to see what the samples are telling us. And then we will decide whether this is going to be a less than or a greater than based on how we choose to make this.
So it doesn't matter if the text stated that less than or greater than in the problem?
Well, in the problem, it has to be consistent with what the samples are. Okay? If I had this situation and the problem said to me, can you prove that P1 is greater than P2? I would say no. There's no way. I can't prove that this is greater because my sample said it's less. Okay? The big difference is that in the textbook, they say, can you prove a difference? Then they make that a two-tailed test. But we're not going to do that. We're just going to, from the samples, we're going to decide whether it's less than or greater than. And that's what we do. Okay? Now, I would certainly, how shall I say this? I will not judge you, all right? If you decide to do a two-tailed test and you do it properly, I would not say, oh, you're a horrible person, right? I might, you know, if it's a 15-point problem, I might take off a half a point or something like that. But the big deal is that you would need to be able to set up the problem as a one-tailed test consistently, so that if it is less than, it's left-tailed, you have the correct critical values and are able to make that process work. Yes. All right, any other question about anything? All right, so Sarah, if you push the button on the video recorder, we'll take a break for 10 minutes. We'll come back and start